So we're going to look at hyperbolas today. So that's the last of our conic sections. So if you have that purple sheet, this is what they're going to look like. So there's a ton of stuff going on here, but they're actually really easy to grab, and they're kind of similar to our ellipses that we just did. Look at your standard forms. What's the only thing that's different? Minus, yeah? So all the stuff is still going to work the same way, okay? Instead of us having like your little ellipse and one side being longer than the other, you've got these curves going on, and you've got asymptotes that tell you where those curves go. So whichever variable is first tells you which direction they open. Yeah, so that's that. Oh my gosh, I almost knocked this camera over. There's a bunch of information up here that tells you how to find all these things, but I think it's almost easier to just do one. Is that okay? So we're just gonna do it. So yeah, for our first one, we want to find the equation of a hyperbola with the center at the origin. So we're just gonna have x squared and y squared. And then we've got a focus at 3, 0 and one vertex at -2, 0. So I think that it's helpful to go ahead and graph what we can. So I'm going to go ahead and put our center on there at 0, 0. And then it tells us we have a vertex at -2, 0. And then we have a focus at 3, 0. 1, 2, 3, 0. So if you have a focus at 3, 0, you also have one at -3, 0. Y'all remember how we talked about that yesterday? If it happens on one side, it's going to happen on the other side too. So we're going to have another focus at -3, 0. And since we had a vertex at -2, 0, you're going to have another vertex where? +2, 0. Is that okay? We all good with that? So right now we just have a bunch of dots on a line. That's super helpful, right? So we're going to use this formula, same as yesterday. So since your focus and your vertices are on the x-axis, that means the x comes first. Is that okay? So you're going to have x squared over something minus y squared over something, and it's still got to equal 1. So just like yesterday, we get those numbers on the bottom from how far out the sides and how far up and down we went. So how far from the center did we go to get to the vertex? 2. Square that, what do you get? 4. That's going to go under your x. Is that okay? Yeah, we still good? Any questions so far? All right, so it's kind of hard to tell on this one because it's really small, so I'm going to show y'all on here. When you go from your center to your vertex, that's your A value, right? That's what we just found. It was 2 for us. When you go from your center to your focus, that's your C value, just like it has been every other time, right? So we know that from the center to a vertex, that A value was what? 2, right? And then from the center to the focus, that C value, how far did we go? 3. Are we good with all that? So you're going to use the C and the A to solve for your B. We're using, it's almost the exact same formula as yesterday. It gives you this one up here, but again, I don't like it solved for B, so what I use is C squared equals A squared plus B squared. That's what we'll be doing. I should probably just change the notes and use that instead. But yeah, so if you're trying to keep things straight, yesterday we added in the standard form and subtracted here. And for hyperbolas, you're going to switch. You're going to subtract in the standard form and add to find your focus. So if that helps you keep it straight, you can think of it that way. So then we're going to solve for B squared. So we'll say 3 squared equals 2 squared plus B squared. So 3 squared gives you 9. 2 squared gives you 4 plus B squared. So 5 is going to be B squared. So square root 5 would be B for us. And then when we square that to put on the bottom, it's just 5. Is that okay? So that's your equation. Do we have any questions on where that stuff came from or how we did anything there? So again, very, very similar to what we did yesterday. So when I'm doing hyperbolas, I like to draw like a dotted box on the inside, and when we're graphing them straight from the equation, it's going to make a little bit more sense. So you go the square root, just like yesterday, out in each direction. So that was here and here. And then for the y's, you're going to go that far in your top and bottom direction as well. So the square root of 5 is what? Like 2 point something, right? So we're going to go like 2.5-ish up. So go up 2 and some change, and then down 2 and some change. And then I like to put a dotted like box around this. So what I'm saying is like connect your vertices in the box you just draw. Did that make any sense at all? It's gonna make more sense in a second. When you go to graph these, you've got asymptotes, which I think you can see on your purple sheet, the vertices. The vertices are inside, the focuses are outside. They're further out this time, which is like a little backwards. You've got these asymptotes here. So do y'all see this dotted box right here? That's what we just drew. Okay, so it's going to make more sense when we do the next one, I think, because we're going from the equation just to the graph. And then you've got the asymptotes, and your formula for that is right here. So it's going to be plus and minus your y over your x, or your b over your a. So for ours on this one, we're going to have y equals plus and minus, because you're going to have the slope going in both directions. It'll be square root 5 over 2x. And so the easy way to graph those, if you have your box, just do like a dotted line connecting the corners of your box, and then like continue it. Does that make sense? Do I kind of get what I'm saying? And so since this one is not a very nice slope, I mean, we got square root 5 over 2. That's not easy to draw, or not easy to count, so it's going to be a little off on this one, but that's okay. So just do the best that you can. So again, I'm connecting the corners of the box and just drawing an asymptote cutting through those. Does that make any sense? So you do the same thing in the opposite direction, just connect the corners of your box, draw your asymptotes around it. So then to graph that, we're going to be going to the left and right and just tug the asymptotes. Make sure you hit your vertex, and that's it. So get close on one side and close on the other, and you're all done graphing. So you don't have to worry about finding exact points like we did on the others, which I think can be tricky sometimes. So yeah. Questions? I hope this makes more sense when we do the next one. I know that was kind of like weird, but that one just wanted us to find our equation. So there it is, and yeah. So looking at the next one, I should probably switch these because it would be so much better to do this one first. We've got x squared over 16 minus y squared over 4 equals 1. So since the x comes first, it's going to open on the x-axis. Square root 16, what do you get? 4. So that's how far we're going to go in the x direction. And then square root 4, what do you get? That's how far we're going to go in the y direction. Where is our center? Where are we starting? 0, 0. I'm going to put a dot there. And then we said we would go 4 in the x direction. So 1, 2, 3, 4. 1, 2, 3, 4. Those are your vertices. Okay? Do you want to go ahead and write those since it's asking for them? Where did they happen? Negative 4, 0, positive 4, 0. Is that all right? So then the y direction, we said we were going to go 2. So go up 2 and down 2. And then do dotted lines to like make your box connecting those points. So like the box is not actually like on the graph. Just like asymptotes are not actually on the graph, right? When you like graph it in your calculator, they're not going to show up. It's just to help you get the right curves going on. So then from there, your transverse axis, that's just asking you which axis it opens on. So that's the x-axis. Let's go ahead and get the equation for our asymptotes. Yes. So that's going to be y equals, and you do plus or minus your b over your a. So ours is going to be 4 over 16. Is that correct? Or excuse me, 2 over 4. You square root those numbers. So 2 over 4 is what? 1/2 x. Is that okay? So if you have a nice easy slope like that to count, it's easy to make your asymptotes. Like the one we did before was not super easy, but this one's easier. So we can go up 1 over 2, up 1 over 2, and just do that over and over again until you get your asymptotes in there nicely. And you'll do it in both directions. So we're going to do the positive one and the negative one. Is that okay? So you're counting your slope. I did the positive one first. So up 1 over 2, up 1 over 2. All right, I'm going to finish my graph. Down 1 over 2, down 1 over 2. And then connect those. There's one of your asymptotes. Okay, that's the positive 1/2 x. Yeah. Then to do the negative one, same thing. You're connecting the opposite corners of your box, or just going down 1 over 2. However you want to think of it is fine. And we'll connect those. That's going to give us our second asymptote. Are we okay with that? Well, we're not done with the graph. We need to get our curves in there now. So we said that it's going to open on your x-axis. So basically, just hug the curves, make sure you hit your vertex. And that'll be your graph. And then we'll find our focus in just a second. So to find your focus, we need that c value. So you're using c squared equals a squared plus b squared. So what is a squared? 16. What would b squared be? 4. 16 plus 4 gives you 20. So c is going to be square root 20. Is that okay? Now, since we're opening on the x-axis, we're going to take the focus values and add to the x values of your center. Does that make sense? So just like we were doing before, you added it to the longer side. Well, there's only one side to add it on. So we're going to be adding to our x's. So you're going to have positive square root 20, 0. And then you'll have negative square root 20, 0. So we're just adding that c value to the center. And we put it on the x's because it opens on the x-axis. Is that all right? Questions? Yes, no, maybe? I'm seeing some confused faces, so what are we not sure about? What do we not understand? We don't understand x? Is that what we said? Do we not understand why we added it to the x values here? Do we have questions? Okay. I'm assuming you don't, so if you do, ask them later, I guess. So those were all on opening on the x-axis. So the next ones are going to be opening on the y-axis, but it's the same deal. They've changed we'll still use the same formula, c squared equals a squared plus b squared. And the only thing that's going to be different for these is because they're opening on the y-axis, the y squared is going to come first when we write our equation. So we need to get this equation in a form that looks more like this. So what do we always have to equal? 1. So what should you divide by? 4. So we're going to have y squared over 4 minus x squared over 1 equals 1. Is that okay? The 4 is hard to see there because the y. So where is your center going to be? Still at 0, 0. So we could go ahead and put that in. And then under the y's we have a 4. So how far are you going to go in the y direction?
4, 2.
Square root that. So go 2, up 2, down 2. Those are your vertices. Let's go ahead and write those. Where are they at? 0, positive 2, 0, negative 2. Is that all right? So there's a 1 under the x. So square root that. How far do you go in the x direction? 1. So from the center, you're going 1 block to the left, 1 block to the right. Then you can make your box from there. Our transverse axis on this one is the y-axis because the y comes first, so that means you're opening on the y-axis. And then to get our asymptotes, we'll still do y equals plus or minus a over b. So it's basically just the back one. Is that the back one? No. they switched in this one, so it's A over B and A over B. I like to draw the box and then just count the slope of the box. Does that make any sense? So like the formulas to me get confusing because it like switches which A and B where and all that stuff. So if you look at our box, we went up 2 over 1. So what should your slope be? 2. Does that make sense? So just count the slope of your box. Are we good with getting the box? Is that easy for everybody? We're good with the box? So then your asymptotes are just going to come from the slope of your box. So go from the center of your box up to a corner. That's your slope. Is that okay? So we'll do plus and minus 2x. Yeah? Does that make any sense? If you count the slope of your box, so from the center up to a corner, we went up 2 over 1. Is that all right? And so that's going to work every time. Whereas like if you're trying to memorize the formulas, I think they get confusing. Maybe that's just me. If you want to memorize the formulas, go for it. But I think it's easier to count the slope of the box every time. So that's what I'm doing. So we got our asymptotes. So you could continue those slopes in both directions so that we get our asymptotes sketched in, and then we'll graph it and then find our focus. So we're going up 2 over 1, 2 over 1. And then you'll take it in the negative direction as well. So just make sure that you're doing that. And we said it's going to open on the y-axis this time, so instead of going to the sides, we'll just go up. Make sure you hit your vertices and hug the asymptotes, and you'll be good to go. And my graphs are real ugly, but that's okay. Such as life. So the last thing that we need to do is get our focus. So the formula you're using for that is c squared equals a squared plus b squared. So what is like our a value here? 4. And that's already squared, so we're good to go there. Plus 1. So your c is going to be square root 5. Is that okay? So 4 plus 1, 5, square root 5, square root 5. So then we're going to add those to our center to get our focuses. So do we need to add to the x value or the y value this time? The y, because you're opening on the y-axis, right? So we'll have 0 and then positive square root 5, then 0, negative square root 5. Questions on that? Is it starting to make a little bit of sense? Do we see how this overlaps a lot with your ellipses? Yeah, I hope. All right, so moving on to the next one. So for the next one, we need to find the equation of a hyperbola that has one vertex at 0, 2. So I'm going to go ahead and plot that. So at 0, 2, we have a vertex. So where are we probably also going to have a vertex?
0, negative 2.
0, negative 2. Since those are your vertices, are we opening on the y-axis or the x-axis? So what's going to come first, x squared or y squared? Y squared. So we're going to have y squared over something. Do we know what that something is yet? How far did you go up from the center to get to those vertices? We went 2, right? From the center at 0, 0, we went up 2. So square that. What do you put on the bottom? 4. Is that okay? Yeah, no, baby? That make sense?
Is the center to the focus C or center to the vertex?
Center to the focus is C. Center to the vertex is A. So then it tells you you've got to focus at 0, negative 3, 1, 2, 3, and 0, positive 3. So we know that it's going to be minus x squared over something equals 1, and we've got to find that something that goes under x. So since they gave you your focus, that kind of helps, right? So we know that your A value was 2. Do you agree? Because that was how far we went from the center to the vertices. Then from the center to the focus, how far did you go? from the center to the focus, how far did we go?
35.
3. So your C value is 3. So you've got to set up that C equation to solve for your B. So we've got 3 squared equals 2 squared plus B squared. So 9 minus 4 gives you what? 5 equals B squared. So B is going to be square root 5, but really we just need B squared to go under here, so I'm just going to put 5. Is that okay? So then that tells you that in the X direction, how far out would we go?
Square root of 5.
Square root of 5, so like 2 point something, right? So we'll just go 2 and a little bit further. 2 and a little bit further. So you could count your slope on these, which is going to be a little bit tricky, but you're going up to and then over square root 5, right? It would be like the slope of your box there. Does that make sense? So that's going to give you your asymptotes. So you could say y equals plus or minus, we did 2 over square root 5x. And again, those are not going to be easy to count, so I would just connect the corners of your box and then try to extend that slope the best you can. It doesn't have to be exact. And then are we opening on the y-axis or the x-axis? Y-axis, so just connect your vertices and hug the curves. You'll be good to go. Is that all right? Questions? Do we need to write somewhere that the A value is from the center to the vertex and the C value is from... Okay. You ready to try the next one? Yeah? Alright. So what do we need to do with this formula before we can start graphing? Divide by what? If I can hold on to my pen, that'd be great. Divide by 36. So 9 over 36, what does that reduce to? 4? I think I heard somebody say. And then 4 over 36, what does that reduce to? 9 equals 1. Is that okay? So where's our center here? 0, 0. Your transverse axis, that's the one that you open up on. What is it? Why is it X? Because X is in front. Okay, so let's go ahead and get our center and we can graph this. So our center's at 0, 0. How far are we going to go in the X direction? 2. How far do we go in the Y direction? So 1, 2, 3. Draw your little box, and then we'll count the slope of the box to get our asymptotes. So from the center to a corner, we go up 1, 2, 3 over 2. So your asymptotes are going to be y equals plus and minus 3 over 2x. Is that okay? Are we kind of getting how those work, or how to find those? So again, once you get that box drawn, you just count from the center to a corner on the box, rise over run. That'll give you your slopes there. So then that's easy to count, so we can get some pretty good asymptotes going here. 3 over 2. So where are our vertices for this one? Why is it at 2, 0 and negative 2, 0? Because you open on the X, exactly. So then to find our focus, what do you need? C, those C values. So you're using that C squared equals A squared plus B squared. So we can just say 4 plus 9. So what is C going to equal? Square root 13. Is that all right? So you're going to add that value to your center. Do we add it to the x value or the y value of your center? The x, because again, we're open on that x-axis. So we'll have positive square root 13, 0, and negative square root 13, 0. And I forgot to draw in the curve, so I'm going to do that real quick. And we're all done there. Okay? Do we have any questions right now? Anything we're not sure about, don't quite understand? So there's a giant table down here that tells you how all these things change when your center is no longer at 0, 0. Nothing's really going to be that different. So, it's about the same. You just have a different center, right? So we're just shifting it somewhere else. The way everything works is still going to be the same. So let's just go ahead and try something. How about that? Okay, cool. So, the only thing that's going to change is when we write the equation for our asymptotes. And do y'all remember a point slope form of a line? Do you remember how to do that? Is that something that we've done before? I think, did we talk about it at the beginning of the year? I can't remember, but that's what this is here. So you use your point, which is your center, and then your slope is going to be the slope of the box, just like we were finding before. So we'll talk about how to do that in a second. Alright, so looking at number 6, we're going to find the equation of a hyperbola with the center at 1, negative 2. So let's go ahead and plot that so we know our center is at 1, negative 2. And we can go ahead and start writing our equation as well, right? So, we can hold off. We'll hold off so we know which one to do. So you have one focus at 4, negative 2. So I'm going to draw that at 1, 2, 3, 4, negative 2. So because we know which direction our focus is from the center, you should know which axis we're opening on, right? So what's going to come first? Yeah? Does that make sense? We okay with that when we go write our equation? You have one vertex at 3, negative 2. 2, 3, negative 2. So that's right there. And just like we had 2 on this side, we'll have them on the other side as well. So, how far away was your vertex from the center?
2.
2. So I'm going to go ahead and write that. A was 2, which means if we count 2 blocks the other direction, that's going to give you your other vertex. Is that okay? Yes, no, maybe? How far away from the center was your focus?
4.
3, so we could say that C is going to be 3. Do y'all want to solve for B now, or go ahead and write our equation? So go ahead and do B? Okay, so you're using that C squared equals A squared plus B squared. So we've got 9 equals 4 plus B squared. So 5 equals B squared. And we could say that B equals square root 5, doesn't really matter. Are we okay with that? So now we can write our equation. So which variable do we say comes first? Your x. So we'll have x, what? Minus 1 all squared over. How far did we go in the x direction? 2. Square that, you get. That's what goes below the x. Is that okay? Then we're going to have minus for your y's up top. What are you going to have? Plus 2. All that squared. And then our b value we got was square root 5. So when you square that, we'll just have 5. And the whole thing equals 1. We can go ahead and plot our second focus. I didn't do that. So that's just going to be 3 blocks over from the center. 1, 2, 3. So it'll be right here. Square root 5 is like 2 and some change, right? So we can go ahead and do your box from that. So we'll go up 2 and a little bit, down 2 and a little bit. And you can get those sketched in. So when you go to count the slope of your box, we went up square root 5 over 2 and over 2. Does that make sense? Because that was where we went like the 2 and some change. So it's plus or minus square root 5 over 2 is your slope. So I'm going to write that slope. So when we go to get our asymptotes, it's going to be a little bit different this time, because we've got to do that point slope form of the line. I feel like I want to do like everything right now, and I feel like I'm not finishing anything. So do y'all want to finish the graph first or write our equations first? If I ever get like that and you want to do all the things at once, then you don't get anything done, that's how I'm feeling right now. Graph, finish the graph? Okay. So this is going to be one of those slopes that doesn't come out so nicely. So again, just like connect the corners of your box and do the best you can to sketch a slope in there or a line in there. And then we're opening towards the X direction. So just make sure you pass through that vertex and hug the asymptotes. So when I'm talking about point slope form of a line, that's like y minus y1 equals m times x minus x1, where the x1 and y1 are a point that you pass through, and the n is your slope. So this is like the form that you're going to use for your asymptotes. The point that you'll use every time is your center. So on the previous page, when it gives you those formulas, it uses h and k there. So that's your center, so that's where that's all coming from. So when we go do that, we'll have y minus, what was the y value of your vertex? Or not your vertex, sorry, your center. -2, so we'll put minus -2 or plus 2 equals. Our slope was plus and minus square root 5 over 2. And then we'll have x minus the x value of your center, which was 1. And that's the equation for your asymptotes. Is that okay? Yeah? Questions there? Alright. So if we're good with that, we've got one more and then we'll be done. So looking at the last one, we've got to get this equation in standard form. So what do you think we should do? We need to complete the square, right? So I would go ahead and put the y's in the front. Why? Why do you think that? Because the y is positive and the x is negative. Does that make sense? So what axis is this going to open on? The y-axis, right? So we already know a lot about this graph just by looking here. So I'm going to put the 4's in front, or not the 4's, the y's, and we're going to have to factor out a 4 from those guys. So we're going to have 4 and then y squared minus 4y. What would we have to add to complete the square there? Because it's positive and the x is negative, so we're going to have y minus x. Because that's your standard form for a hyperbola. Is that okay? So whichever one's positive, put it first. Does that make sense? What?
Got it.
Okay. What do we add to complete the square? 4. When we add to the other side, what are we going to have to put? Why is it 16? Because it's 4 times 4. Good. Then we've got our x's. So I'm going to pull out a negative from the x's before we complete the square. So we're going to have negative x squared and then plus 2x. Is that okay? Because you want your leading coefficient to be positive when you're like doing completing the square stuff. So what do we add in to complete the square there? Plus 1. But really, it's a -1, so we'll have a -1 on the other side. And we moved that 11 over, so we've got a -11 over there as well. Is that okay? Are we all good with that? We did a lot of things all at once there. Alright, so when you factor out the y's, what do we get? Y minus 2 all squared. And from the x's, what are we going to get? X plus 1 all squared. And then we've got -11 plus 16 minus 1. Comes out to 4. What do we have to do as our last step here? divide by 4. So we've got y minus 2 all squared over 4 minus x, over 1, sorry, not over 4, I was thinking of the x one, plus 1 all squared over 4 equals 1. So that should be a 1 under the y's. We all right? Yes, no, maybe? Questions? All right, so where's your center? Negative 1, 2. So we can go ahead and plot that. Negative 1, 2. Which axis are we going to open on? The y, we already talked about that. So that means your vertices are going to be with our y's. So how far in the y direction do we go? 1. So go up 1 block from your center and down 1 block from your center. So where does that put your vertices? Negative 1, 3, and where else? Negative 1, 1. That okay? How far do we need to go in the x direction? 2. So we'll go over 2 and 2. So you can go ahead and get your box from there. Your transverse axis is the axis that we opened up to, and we already said that's which one? Your y-axis. So it's going to open up and down. To get our asymptotes, do y'all want to do that now? We'll do that now. What's the slope of that line going to be? So count from the center to a corner of a box. Up 1 over 2. So 1/2 would be your slope. Is that okay? All right. So when we go to write that equation, you're using that point slope form again. And the point you use is your center. So you're going to have y minus the y value of your center, which was 2, equals your slope. We have plus and minus 1/2. Times x minus the x value of your center. So we'll say plus 1. Is that all right? Those are our asymptotes. Can you see that? It's kind of running out of room here. So we can go ahead and sketch those asymptotes in up 1 over 2. And we said we'll open on the y's, so they're going to go up this way. The last thing we need is our focus. So the formula that you're using for that is what? So basically just 1 plus 4. Is that okay? So 5. So c is going to be square root 5. So we're going to have to add that to your center. Are we going to be adding to the x's or the y's? Why do you add to the y's? That's the direction you open, yeah? So we'll have negative 1, 2 plus square root 5, then negative 1, 2 minus square root 5. That all right? Okay, cool. So, you didn't get time to take pictures of the homework. So what I can do is send them to y'all in an email. Does that sound good? Yeah? Alright, so grab the answer sheet on your way out, and I'll email y'all the questions. Yes, sir.
You put them on mine too?
I put them on their minds. Is everybody in their mind group? No. Okay, I'll email them and I'll remind them. I'll do both. I'll try to do both anyways. I'll use this school email. Do you have one of those?
Yes.
Do you want to me to send it? Here, tell me where you want to send it.
School email is fine. I'll tell
Hey,
you
were you
tomorrow.
saying that?
And I'll just work on it over the weekend. Okay. All right.
Will you be okay for the quiz tomorrow? Without having to practice? Okay.
There's a good note. It is. Yeah.
Versus on the video where one put picture in the past.
Oh my gosh, I'm still recording. Wonderful.